Okay, continuing the practice problems. Number 7, find the slope of the line through 2, 5, and 8, 8. Okay, delta y over delta x. The change in y values will be 8 minus 5, and the change in x values will be 8 minus 2. So that's 3 over 6, and that reduces to 1/2. Number 8, find the slope of the line through negative 2, 5 and negative 2, 1. Okay, same thing, delta y over delta x. The change in y is negative 1 minus 5, and the change in x is negative 2 minus negative 2. Negative 1 minus 5 is negative 6, and negative 2 minus negative 2 is the same thing as negative 2 plus 2, which is 0. So division by 0 is undefined. So the slope here is undefined. This is a vertical line. And you can see both of these points have the same x coordinate. So they would be right on top of each other if they were graphed. Or one, not right on top, but one above and one below. They would be lined up vertically if they have the same x coordinate. So it's a vertical line, so we can't put a number on the slope. Okay, number 9. Find the slope of this line, 2x plus 4y equals 8. Do this. Draw a little x and y axes. We'll make just a rough sketch here to show this graph. And find the intercepts. If x is 0, then we're left with 4y equals 8. So y is going to be 2. So let's plot that, write a little 2 there. And then think if y is 0, we're left with 2x equals 8. So x is 4. So plot a point there. There's 4. So our line will look something like this. So you can see that if we moved from point 1 to point 2, we would go down 2 and over 4. So the slope here would be negative 2 over 4. And that reduces mathematically to negative 1/2. This line has a slope of negative 1/2. We'll approach number 10 in a similar manner. Draw a little xy axis here. And first imagine x being 0. Then we have negative 15y is equal to 45. So y would have to be negative 3. So let's plot a point down here and write negative 3. And then let's imagine the y being 0. 3x equals 45. That would be true if x were 15. So plot a point there and write 15. Okay, so the line looks like that. It really goes on infinitely, but we're concerned with the rise and the run between those 2 points. And going from one of those points to the other, we would go up 3 and over 15. So the slope here would be 3 over 15. And 3 over 15 is 1/5. And then problem 11 down here. For the data given, plot the points and graph the line. Find the slope of the line and explain what the slope means. Okay, here we have number of gallons and number of miles driven. So this is presumably gallons of gas. And let's plot these points. 4 gallons, 60 miles. So about right there. 8 gallons, 120 miles. About there. 12 gallons, 180. And 16 gallons, 240. Okay, those are the points. I'll draw in a line there. We need the slope of the line, so I'll pick 2 points. I'll use these 2 down here. And let's calculate a rise and a run from those points. So I'm using these 2 most extreme points. So the rise here Going from 60 to 240, that's a rise of a 180. And that's in miles, 180 miles. And then the run, how far over we went, well, we went from 4 to 16, so that's a change of 12. 16 minus 4 is 12. That's 12 gallons. So the slope is 180 miles over 12 gallons. And 180 divided by 12, that reduces, right there, 180 over 12 reduces to 15. So we divided 180 by 12 and got 15, but the units here are still there, with miles up top and gallons down below. So this is 15 miles per gallon. So as far as what the slope means, that's the gas mileage of the vehicle, 15 miles per gallon. So let's just write that. The gas mileage of the vehicle.